You're falling into a black hole. Do you hit the bottom of the universe or blast off to another dimension? Here's why black holes might not just be cosmic monsters. They could be clues to the deepest secrets of the universe, or doors to realms we can't yet imagine. From the smallest quantum mechanics to the largest galaxies, it seems like Einstein was right about everything, except what happens when you fall into a black hole. When you get too close to a black hole, there is no up or out. It's inescapable. And once you cross a certain point called the event horizon, you can never come back. But that doesn't mean that you disappear or get destroyed. It just means that no one will ever see you again. So what actually happens inside a black hole? That depends on whether you believe Einstein or Einstein said black holes have an edge. A point of no return. Cross that edge and you stay in the same universe. Just very far away. Feynman said black holes have a center. You fall to the middle of the universe and then you pop out somewhere else. Which one is right? Well, this is a space video, so let's look at the stars. Our galaxy has a giant black hole in the center. Our black hole is called Sagittarius A, and in a few million years, it's going to destroy everything in its path, including Earth. So we better hurry up and learn what it's going to do. But first, we need to talk about what a black hole actually is. Because the truth is stranger than fiction. A black hole is a place where gravity pulls so hard nothing can escape, not even light. This makes them invisible, but you can tell where they are by watching how nearby stars move. A black hole is basically a dot. It's an infinitely dense ball of matter called a singularity. Nothing can escape the pull of a singularity. Not even light. But around it is an area where stuff starts to get weird. This is called the event horizon, and this is where we'll start our story. The moment something crosses the event horizon, it disappears from view forever. We know that because light can't escape a black hole. So, if anything enters one, we can't see it again. But that doesn't mean it's gone forever. Because according to Einstein's theory of general relativity, everything that falls into a black hole continues to exist. It's just trapped there. But that raises a problem. If black holes really do trap everything, including light, how can we know they exist at all? Well, here's the thing. Black holes aren't totally black. In fact, they glow. It's just that their light is stretched so much that we can't see it. This phenomenon is called the Unruh effect. It happens to anyone who accelerates through space, which you are if you're anywhere near a black hole, even if you can't see it. Basically, the more gravity you feel, the more you glow. But since black holes have lots of gravity, the Unruh effect almost cancels itself out. But that tiny bit of light that does make it through is what we call Hawking radiation, after the physicist Stephen Hawking, who predicted it in 1974. It's thanks to this radiation that black holes aren't entirely black. And it's also what could help us understand what they're made of. You see, the thing is, physicists don't actually know what a black hole is made of. According to Einstein's theory, nothing gets out of a black hole. Once it goes in, it stays in. But Hawking radiation suggests otherwise. It means black holes aren't entirely black. They glow. And if we can figure out what that glow looks like, it could tell us everything about what's inside. Okay, now let's go back to the beginning. You're falling into a black hole. As you approach the event horizon, everything begins to slow down until time seems to stop altogether. From your perspective, you never reach the event horizon. You never cross that point of no return. Because from your perspective, the event horizon never moves forward. It stays right where you are. For everyone watching you fall into the black hole, it looks like time stops. But you won't experience that yourself. That's because of a phenomenon called time dilation. It happens whenever you're near a black hole. The closer you get to the event horizon, the slower time goes for you. Eventually, it would seem to completely stop. But that's only because you're getting closer and closer to the black hole. To someone far away, you'd appear to be frozen in time, endlessly approaching the horizon. But to you, time keeps moving normally. In fact, Things look totally normal to you until you actually cross the event horizon. But that doesn't mean that crossing the event horizon is easy. For one thing, it's pretty hot. As you get closer to the event horizon, the gravitational forces get stronger and stronger, squeezing you tighter and tighter. It's called spaghettification because it pulls you into a long, thin shape like a strand of spaghetti. Also, the closer you get to a black hole, the less time you have to react. Because, although you wouldn't notice it yourself, from far away, everything near a black hole appears to slow down. And that means if you wanted to do anything about what's happening to you, like turn your spaceship around and blast away from the black hole, you wouldn't be able to. You simply wouldn't have enough time. So, if you want to know what really happens inside a black hole, you've got two options. Either you can sit tight and wait for the inevitable, or you can jump in and hope you don't get crushed. But that raises a question. How big is a black hole? Well, that depends on how much mass it has. A star that's roughly the size of our sun, but has about 3 times its mass, will collapse into a black hole after it explodes as a supernova. These are called stellar black holes, and they typically measure about 20 kilometers across. However, these are relatively small fry compared to supermassive black holes, which are found at the centers of most galaxies. They can be thousands or even millions of times heavier than the sun. But the exact mechanism behind their formation is still unknown. Now let's finally answer the question. What happens if you fall into a black hole? Well, there are 2 main theories. One says that nothing happens. You just get crushed by gravity and turned into pancake batter. The other says you get teleported. So which one's right? Well, the truth is we don't know. But here's what we think might happen. First, you'd feel the intense heat of the Hawking radiation. Then you'd feel the gravitational forces start to pull and stretch you until you were a pancake. Next, you'd pass through the event horizon and fall into the singularity. And then, well, we don't know what would happen next. Some scientists think you'd get crushed into a pancake of subatomic particles. Others think you'd get teleported to another part of the universe. The reason for this is that black holes are thought to be a wormhole is a tunnel through space-time that connects 2 distant points. And the idea that black holes are wormholes isn't all that crazy. It comes directly from Einstein's equations. In fact, the solutions to Einstein's equations predict that black holes should be wormholes, called Einstein-Rosen bridges. But wormholes have a major problem. They're unstable. Any little fluctuation could cause them to collapse. But some physicists think that if they did somehow manage to stay open, they could connect different parts of the universe, or perhaps even different universes. There are a lot of guesses about how this might work. Some people think it would involve exotic matter with negative mass. Others think it would require extra dimensions of space. But we really don't know. However, most physicists agree that it probably doesn't happen at all. That's because if black holes do have wormholes inside them, the radiation would rip them apart before they could do any In fact, the only way we'd know they were there in the first place would be if the radiation leaked out into our universe, carrying information about what's inside the black hole. But Hawking radiation doesn't carry any information. That's what we call the information paradox. According to Einstein's theory, black holes can't do anything but trap stuff. But Hawking showed that black holes emit radiation. And if that radiation carries information about what's inside, that means black holes aren't really black holes at all. Something's getting out. And that means we need a new theory of physics. Some physicists think that new theory will combine Einstein's theory of general relativity with quantum mechanics. Quantum mechanics says that nothing can be in 2 places at once. So if something falls into a black hole, it can't be in 2 places at once. It has to be in one place. Maybe that place is somewhere else. If black holes really are portals to other universes, that could explain some of the biggest mysteries of physics. Dark energy, dark matter, and the origin of the universe. But it would also mean that we're not alone. There could be other universes out there. Other versions of ourselves. It would be like finding another Earth, except it would be a different Earth. And maybe those Earths would have different laws of physics. Maybe they'd have different constants, like the strength of gravity or the charge of an electron. Maybe they'd even have different dimensions. Maybe if you fell into a black hole, you wouldn't just fall into another universe. You'd fall into another version of yourself. You'd fall into yourself, a version of you that lived a slightly different life. You'd fall into yourself. A version of you that didn't fall into a black hole. So what happens if you fall into a black hole? Does it lead to another universe? Does it destroy you? Or does it bring you face to face with yourself? Let us know what you think in the comments below. If you liked this video, you'll love our video on time travel. We'll see you next time.